Hello everyone and welcome to this new webinar. This is Jordi Miró, Product Engineering Manager at Ignion, and in collaboration with Chipselect, we will see in smart metering in terms of antenna integration, how to have enhanced and optimized RF performance for your device, dealing with this typical challenge that you must face when you are developing a smart metering. We know that electricity, water, and gas consumption data gathered from millions of meters requires highly reliable and efficient wireless communication. Smart meter manufacturers and metering solution providers are faced with multiple RF design challenges. So we will see all of them, or at least the most typical ones, like choosing the optimal wireless technology for a given geography, optimized device designs, covering multiple radio frequencies, ensuring always high efficiency and low power consumption, taking care of the physical environment. For example, in this image in the cover, we have smart metering deployed in which is like a metallic wall, but also for concrete or wood, or even brick. All of these materials make an impact on the antenna, and it's always very recommendable to assess the performance of the antenna in these cases, in all of these cases, as per your deployment case. Also, we will see how to meet certification requirements and the best practices to reach them. All of this thanks to the virtual antenna technology, the technology that Ignion owns, and basically is the technology is based on make RF antenna challenges easy to solve, making robust connectivity possible. Also thanks, and we will see in the next slides, thanks to the cloud-based design tool based on our 20 years of experience. This technology, this virtual antenna technology, is a family of 6 products so far that are able to cover from 400 megahertz, covering, for example, the LTE 450, up to 10.6 gigas. So it's multiband and has tunable coverage, covering any regions with one antenna through the matching network, a solution that we will see in the following slides. Also, considering environmental challenge, anticipating the effect of materials in proximity, and of course the battery efficiency, the battery consumption, thanks to a high antenna performance. The virtual antenna technology enables low power consumption. So, to give you some context, the Ignion solution consists in 2 parts. We have the hardware part, which basically is the virtual antenna technology, and consists in 3 main elements. The first one is the antenna component, as you can see in this slide on the left, the red part number. We have 6 like these red small part numbers that are non-resonant antennas, so they are able to cover any frequency range thanks to the matching network circuit. This series of lamped components, it can be inductors, capacitors, and 0-ohm resistors, that are able to tune the desired frequency range. Being single band, multi-band, it doesn't matter. Thanks to this matching circuit, you can tune the antenna response to your needs. And once the antenna is tuned to the desired frequency range, the ground plane, as the main radiation element of the system, is the one that is in charge of enhance the antenna performance. So typically, the bigger the ground plane, the better the antenna performance. So it's because the virtual antenna solution take advantage of the ground plane to radiate. But you can think that, okay, those are 3 elements, okay, quite easy, quite simple, but for me it's complex because I'm not an antenna engineer, I'm not an RF engineer, I am hardware engineer, but I don't have an idea, I don't have a clue about antenna integration. That's why Ignion solution consists in 2 parts. The software part is the Antenna Intelligence Cloud Design Tool, which is a tool, cloud-based. You can access to that free of charge in our website. We can make a demonstration after. That in tandem with the versatile virtual antenna technology, our antenna intelligence cloud ensures your design gets on the right path from the beginning. So, but basically is an AI machine learning powered digital twin, and we only introduce the PCB dimensions, the wireless technology, and the frequency range associated to this wireless technology. You can also choose between our 6 pair numbers, but in case you don't know which one is the best fit for your device or your case, the system will choose for you the optimized one for your specific design constraints. So basically, once you fill out the form, it's a 1-minute form, you will receive a comprehensive report and design files for your device with the antenna location, clearance area for your antenna, matching network, topology, bill of materials used for this performance estimation. Also included total efficiency and S11 or reflection coefficient for this matching network solution or this antenna solution. And in case of smart metering, you will get additional slides in this report with design recommendations and best practices for your device in terms of antenna integration. So basically, it's very accessible. You can go to ignion.io, and in the top right corner you will see antenna design tool. So you can access there and use the tool to get your device ready to the market. So before starting, we can evaluate most of the typical challenges that the smart meters face when are dealing with antenna integration. Some of them are this multi-board connection. One of the typical use cases for smart metering is having the main board with everything related to batteries and other LCDs and so on for metering, and also separated from this main board we have the communication board that in this case, one of the success stories that Ignion has is this smart meter that is connected it's like a hat, something like a hat. It's a new car that is plugged or unplugged, and you can change the wireless technology. So you can just have your main board with different wireless technology just by plug the communication board. So this multi-board connection can makes an impact on the antenna performance. So we will see how to take advantage of that, because you can affect antenna performance if you don't take care of this connection. But I mean, we can take advantage of that, so we can have better performance compared with just the PCB board for the antenna, for the communication board. Thanks to this connection, you can improve the antenna performance. So it is very interesting to consider this connection. Also, the 450 MHz, this new LTE band for metering, in combination with LTE-M or Narrowband IoT, it is very complex solution. It's a very wide frequency range. So we will see how to deal with this challenge. Also, considering materials in proximity, as we said, the deployment of your device, where it is deployed is very important. So if you are, if your meter is deployed in a metallic wall, you need to assess the performance of the antenna in this case, in this environment. It is not that critical for a concrete or brick wood. It's not that critical. Maybe you can experiment. We will see in the next slide, but the most important one is to assess the performance in very metallic environments. We will see also the certification part and the best practices to reach all the carrier certifications for your device, and of course always ensuring the battery life of your device thanks to a high performance solution allowing this low power consumption. So, as I said in the slide before, we have this multi-board connection integrating communication board with main PCB. In this case, we have the communication board with the red part number, covering LTE 450 megahertz, well, sorry, LTE 450, which is actually 450 megahertz up to 470 megahertz, and it's connected to the main board thanks to this 14 pins strip connection. So both of them, 2 pins, are connected to GND, allowing this connection. Basically, how this works is, as I said before, and how the virtual antenna technology works. The virtual antenna component with the matching network takes advantage of the ground plane to radiate. So the bigger the ground plane, the better the antenna performance. So if this connection, if this array of pins is connected to the main board and the communication board, the virtual antenna component will see more ground plane. So the antenna performance will radiate better than having only the communication board. So basically we will see sorry. So here we can see how the location of this array of pins makes an impact on the performance. As I said, this is very important to locate the best connection point through surface current simulations. This is our electromagnetic simulator with the setup I mentioned before, and we can see how the surface current connects the communication board and navigates through the array of pins and goes to the main board. We can see the surface currents level along the edge of the main board. And we can see, let me use a pointer for that. Okay. We can see how, following this green part, for this specific case, this is the best area to connect the array of pins to be connected to the main board. And we can see how the best part, the green part, is, this is the total, sorry, this is a graph showing the total efficiency of the antenna, okay, which is one of the key values for assess antenna performance. And we can see the efficiency reaching almost 80% of efficiency, compared with a connection, sorry, more or less in this area, okay, that is in the limits of the not recommended connection location, which is this red part. And the more you go in the not recommended connection location, the less efficiency you have. So, as I said, it is very important to take advantage of this connection to ensure the best antenna performance for your device. So this is one of the examples that Ignion provides to customers that are interested in covering this LTE 450 with optimized antenna performance and meeting the certifications that are needed for this specific band, and is a combination of both antennas. This is the OM extend with the 3OM extend, and we can see here the combination of them with a recommended, which is a recommendation to use a switch configuration and having this antenna separated once covering. From 700 megas, I think is a full range LTM solution, and the LTE 450. But also this this can be used also for other wireless, such as ISM, 900 megas, any sub-gigas protocol, 2.4 protocols as well. So the versatility of the solution is very high. So of course, for the analysis that I shown in the slide before, in case you don't have any electromagnetic simulator, Ignion offers services for simulations, for Gerber review, and so on, that we will see in one of the last slides. For all of these steps that I mentioned, let's say the design journey to reach the final device, to be ready for the market. We will see how Ignion solves all of this and how Ignion recommends in case you want to do it on your own, which will be the best design journey to meet all of these challenges. So as I said, one of the key points for having your device ready to the market is assess the performance of your device with the materials in proximity, with the let's say with the impact of the wall that your meter is deployed. So here we will show some of the best practices or recommendations in terms of materials in proximity. One of the key elements, as we can see in the graph comparison at the top of the slide for the antenna efficiency results, you can see the example of having the antenna just touching the material in proximity, and in the bottom of the slide we will see at 2 centimeters or 20 millimeters separation between the wall and the communication board. Okay, that can be easily achieved through the casing. I mean, the space that the case between the communication board and the wall. As an example, the wall, let's say, it will be more or less 20 millimeters, so you will be fine. But if you have the communication board just touching the material, you will see how in the top of the slide, how the performance is quite lower. So one of the recommendations that we provide is keep distance between the antenna and metallic elements. For example, you can see what the green trace for the graphs is when this communication board is deployed in a metallic wall. So we can see for the 0 millimeters or almost touching how the performance is practically zero for the lower bands, and you have very reduced antenna performance for the higher bands. And as I said, for other non-metallic surface like wood, concrete, or of course free space, we can see how the performance is more or less similar to the free space case when any elements is affecting the antenna performance. But always is very important to assess the performance accounting materials in proximity. For non-metallic elements, shifts in the antenna response can happen, but can easily be adjusted through the matching network, as I said, is the one in charge of tuning the antenna response for your device. And you can see a table with the summary of antenna efficiency for all the cases shown in this example. Of course, meeting certifications is something to consider, and for the EDMI smart meter case, we meet all of them by following the best practices that Ignion always recommend for their customers. That is, focus on the deployment bands, which means that if you typically, if you want to cover the full range, the bands that you need to certificate is by region. So typically, it doesn't make any sense to cover a band in your device that is not used in the region you are going to be deployed. So it's very important to focus on the deployment bands as per your region. So you can just address to your local certification corporation to ask for it, or you can just address to us and send us an email, and we will be glad to help you with this. Always follow the design recommendations that are gated in the design in the Antenna Intelligence Cloud report. You can use it from the very beginning of your project, and by following the design recommendations that are gated in the report, you can ensure that the certifications will be met, the certifications requirements. As I said, for ensuring also not only meeting the performance certifications, but also to have a good battery life, a low power consumption, use high Q factor, and low loss components is very recommended. And also you can address to us, send us an email for pre-certification services. So you can perform over-the-air tests to ensure before going to certificate your device that you are going to meet the targets in performance for your specific device. And here is an example of optimizing antenna impedance and a comparison on what happens when you have an optimized antenna impedance and you have good battery life, you ensure a reliable communication. So you can see, let me use the pointer again. You can see this will be where the RF module or the chipset is located, how all the injected power through the module is almost all of them is radiated to the air, so the antenna impedance is very efficient. So you have only losses caused by resistive losses, coupling losses, or other typical elements that is more hard to avoid, and the reflected power is practically zero. And the other case, which is a suboptimal antenna impedance, a disaster in terms of antenna impedance. So you have very reduced battery life, a poor quality of communication, and in the worst case, in the worst scenario, you can damage your own chipset. So your solution needs to come back to feasibility analysis or to design stage. So it will take a lot of time, and the market time is very important for all of you, I am sure. So in this case, we see how all the power injected through the module is reflected again. So the RF module or the chipset will overheat the device to inject more and more power to ensure a communication that is not happening. So this is the simplified virtual antenna design journey. This is the path that we recommend for all of our customers to ensure the first and right antenna integration for market launch, which consists in starting with the Antenna Intelligence Cloud design tool, and you will receive this design files to start with your Gerber files, let's say, okay, to start with the solution with your device, and by following the design recommendations gathered in the report, and also well, yes, ensuring that you meet the design recommendations gathered in this report in terms of antenna integration. And once the Gerber is ready to be manufactured, something happened, you need to make a change on your device, smaller, bigger, you need to change the antenna location. Thanks to electromagnetic simulations, you can assess the performance of your device in case you need to move anything from these recommendations. So if you have other design compared to this one, you can try again with this solution and apply the design recommendations for the other case, or you can just simulate it on your own, or contact Ignion in case of you need electromagnetic simulations and you don't have electromagnetic simulation software, we can do it for you. And it's very important also to assess all the changes that you want to do in simulation before manufacturing. And then once the Gerber is ready to be manufactured, we can review the Gerber for you free of charge after using the Antenna Intelligence Cloud and meet all the design recommendations. You are ready to prototype, and once you manufacture your prototype, there is the matching network fine-tuning. You need to tune, or you need to make sure that the antenna responds for your real device with all the elements that are not included in the simulation, such as batteries, casings, LCDs, so on. You need to make sure that the antenna impedance is matched. Otherwise, you will experience the case of suboptimal antenna impedance. and also assess the antenna performance, testing the materials in proximity. In this case, in case you don't have RF expertise, Ignion also offers services for matching network tuning. So before going to mass production, Ignion can ensure you that you will have optimized antenna performance for your market launch. And before going to certificate, also, as we mentioned, it is very important to assess the performance and make sure that you meet the certification targets. Ignion also offers, with the anechoic chamber in our facilities here in Barcelona, offers pre-certification test, ensuring that you meet the targets before going to certificate. That also makes an important cost for the budget. So to summarize, you can see all of our services in the link in the bottom of the slide, from Antenna Intelligence Cloud, free of charge, the Gerber review, also free of charge services. We have the electromagnetic simulations to assess the performance in case you want to assess the casing impact and so on, the matching network fine-tuning, and the pre-certification test. And that was everything from my side. All of the recommendations, all of the results that you saw in these slides is gated in the smart metering design guide that Ignion published. You can click in the link in the slide or scan the QR code. So you will see recommended antenna design steps with examples from concept performance emulations to certified device. So you will see all the steps from the very beginning, from the feasibility analysis to the manufacturing device meeting the certifications and so on. And you will see also total efficiency impact by PCB size and materials in proximity. So all the steps in terms of antenna integrations are gated in this design guide. I invite you to check out the content inside, and thanks for joining this webinar. It was a pleasure for me, and see you. Thanks.